Hello everyone. Today, my teammates Yuvan and Devaraj and I will be telling you about our plasmid model. In layman's term, a plasmid is a small circular piece of genetic material that is separate from larger DNA molecule. All we need to create this model is a pair of scissors, glue, two paper strips of plasmid backbones colored green, and one paper strip of target gene colored pink. The glue acts as a DNA ligase while the scissors acts as a restriction enzyme. However, cutting with the scissors is quite different from cleaving with the restriction enzyme. While employing scissors, there are no chemical alterations to the material itself. In contrast, when a restriction enzyme is used, it identifies and binds to a particular pattern of nucleotides in the DNA molecule. The enzyme then cleaves the molecule by dissolving the nucleotide chemical bonds at the precise location. Furthermore, scissors are not selective. In contrast to that, the restriction enzyme will only break the DNA molecule at the exact location it detects, making this process extremely selective.
The green color here represents the plasmid's backbone, and then you have a promoter here where the transcription is initiated, and then a ribosome binding site where the ribosome comes and sits here so that the gene gets translated. And then here you have the multiple cloning site. So the pink color here represents the gene of interest. So as you can see, of course, you need a restriction enzyme that cuts here so that the gene of interest can get integrated into the plasmid. Okay, here you can see a sticky end, but then later we'll see into the blunt end as well. And then you have several antibiotic resistant genes here, okay, like ampicillin resistance, kanamycin resistance, and whatnot. And finally, the origin of replication, where the DNA starts replicating. Okay, why? Okay, there are several restriction enzymes that can cleave at DNA at specific recognition sequences that generate blunt ends. Okay, blunt ends. Okay, for example, like the EcoRV. But blunt-ended restriction enzymes cannot be used to create recombinant DNA molecules with the same efficiency as sticky-ended restriction enzymes.
The blunt end restriction site is the CCCGGG, where the enzyme that cleaves it is SMA1. Enzymes cut DNA at specific location but do not leave sticky ends. They still play important roles in DNA metabolism and regulation within the cell.
So a paper model of a plasmid can actually provide a simplified visual representation of a bacterial plasmid and its key genetic features, which can actually be helpful for teaching and understanding the principles of recombinant DNA technology. In terms of size, bacterial plasmids can vary in size ranging from a few kilobases to 100 kilobases, and a paper model can be scaled to represent the appropriate size of a plasmid. Genetic elements. Bacterial plasmids contain several genetic elements such as the origin of replication, over here, antibiotic resistant genes, and other genes that provide a selective advantage to the host cell. A paper model of a plasmid can also include these genetic elements, which are often represented by different colored sections on the paper model.